There are two things. See, we are trying to monitor and control the process. We are trying to monitor and control the process. We might be controlling the output. We might be controlling the input, right? Whichever characteristics which is very critical to me, I will monitor and then control. So what do I mean by monitoring? How it is fluctuating? Any output will fluctuate. Input can also fluctuate. If the input fluctuates heavily, then output also will fluctuate heavily. If you allow the fluctuation to be very heavy, what will happen? It can go beyond acceptable limit, which is called the specification limit. So the purpose of the control chart is to monitor and control the variation. Monitor and control the variation. As long as the variations are under control, as long as the variations are under control, the process is considered to be under statistical control. The process is considered to be under statistical control. If the variations are heavy, too high, then the process is considered to be statistically out of control. See, now my statement is a statistical statement. Statistically control, statistically out of control. Even a statistically out of control process may be acceptable to my customer. Please understand. I am not talking about specification limits here. I am only talking about the variation of the process. If the variation is too high, process is statistically out of control. If the variation is too less, process is statistically under control. To understand, let us say I conduct an examination, green belt examination 3 times, or the black belt examination 3 times. Your marks are 65, 75 and 95. Your marks are 65, 75 or 65, 80 and 95. Now which mark I should consider?
95.
Because you want 95, but you have not performed consistently, isn't it?
Yes.
So statistically you are out of control, but still in all the 3 cases you have passed the exam. Do you understand?
Yep.
But if all the 3 exams, if you have scored around 95, then I will declare it in a statement. I'll declare it in a statement saying that so-and-so has acquired 95% in the exam. So similarly, whether the product is acceptable or not, you require consistency in your process. You require consistency in your process. This is called statistical control. This is called statistical control. Statistical control means all your points should appear inside the control limit. All your points should appear inside the control limit. You know why? We very well know that there is 99.73% chance for a point to appear inside a control limit. All of you agree with my statement? How much chance is there for a point to appear inside control limit?
99.
Come on, you need to answer all this because we have equipped you very well. We have taught you normal distribution. Our
99.73.
99.73. So 99.73% chance is there for the points to appear inside a control limit, and that is not happening. That means something serious. All of you tell me, how many chances is there for you to clear the examination, black belt examination? How much chance is there? Tell me a percentage. We have created a very good percentage, isn't it? Definitely you sit in the classes, just follow the instructions, and you will be through in the first attempt. Right? So same manner, it depends on your process, the chance percentage. Now, let me show you a control chart so that it will be easy for you to understand. So this is, I think all of you are now seeing my screen, am I right?
Yeah.
And any control chart will have 3 lines, a center line and control limit. We call it upper control limit. Another one is lower control limit. The upper control limit will be at a distance of 3 sigma above the center line, 3 sigma units below the center line. But in order to arrive on the control limit and draw the line, actually, we have certain formulas developed by statisticians. These formulas will overcome the limitations of your data. Your data is considered to have a limitation if the sample size is less. Your data is considered to have limitation if there is a problem with the sampling. In order to overcome that, though we know the line is 3 sigma above the center line, there are statistical formulas. What is the idea of the statistical formulas? To overcome the limitations in your data. So that is the reason why we use the statistical formulas and draw the control chart and draw the control limit. After drawing the control chart, after plotting the points, if you see all the points inside the control limit, your process is considered to be under statistical control. And now look at the slide and tell me, is this process under statistical control?
Oh,
Because there is 1 point below the lower control limit. The process is considered statistically out of control. The moment you understand the process is statistically out of control, investigation is required. Investigation is required. For investigation purpose, the process must be stopped. The process must be stopped. You should go to the extent of taking these actions if you are really strong in control chart, right? And you will better appreciate this as you deep dive into the tool called control chart. So the purpose of the control chart is to monitor stability, whether the performance is consistent or not. And control chart will also tell you whether the process is ready for the next level of performance. As far as this process is concerned, this process is not ready for next level of performance because it is having a problem with the current level itself. Do you understand here? The green belt itself, somebody is struggling. Why should he think about the black? Something like that. The process is currently struggling. Don't try to improve the process. But if all the points are inside, I can think, why not I upgrade to the next level? Because I am well now. Why not I improve the process, right? So control chart can give a clue about the readiness for improvement. All of you understand the second statement? My process is going on smoothly. Every single product is getting accepted by the customer. No rejections. Control limit is also stable. And now I can further improve to make my products really world class. That's the point. Third point, control chart can be used as a visual validation tool, like RK was telling. Use the control chart to convince anyone. The process before, there are a lot of out of control points. But the process after the project, all the points are inside the control limit and most of the points are towards the center line. That is an evidence of significant improvement, in your process capability. All of you understand the benefits of using a control chart?
Yes, sir.
Now, in order to understand the control chart, you should be able to draw a clear boundary between two types of variation. Earlier, we studied two types of variation. Process variation, another one is measurement variation. Now, let us consider the process variation. Within the process variation, there are two types available. One is called common cause variation. Another one is called special cause variation. Right? So what is that? And imagine you are going to office every single day using a motorcycle. And it takes 40 minutes for you to reach your office. It takes how much time? 40 minutes for you to reach the office. I am recording your travel time for about a week. This is the data I am able to generate. This is the data I am able to generate. And now tell me, is your traveling process under control? Can you tell me, all of you? Looking at the data.
yes.
Almost, you are following a very good discipline, while going to the office. Always reach office on an average consuming 40 minutes. I am not able to figure out any problem here because though there are certain difference here, plus 2 minutes you have taken here, minus 2 minutes here, plus 1 minute here, minus 1 minute here, though there is plus 1 minute and minus 1 minute of consumption, still I don't see it as a problem. So this kind of variation which is not leading to any kind of suspect are called common cause variation. All of you, do you understand what is common cause variation? There is a variation in your data, still it is not leading to any kind of suspect, right? It is not leading to any explainable reason. You can't explain the reason. Imagine, I'm just asking you, why do you took 2 minutes extra while coming to the office? There is no reason. I was just riding the vehicle all the time, and by the time I reach office, it took 42 minutes. Same thing I did other day, but I could reach 2 minutes early. Absolutely, there is no reason you could explain. Am I correct with my statement?
Yeah.
Whenever you are not able to explain the reason for the variation should be considered common cause variation. Now, another day, you are able to reach office in 25 minutes. Now tell me, do you think you will be able to give a reason now?
Yes.
Possible reason, one of the possible reason, can you tell me? What could be the reason
Traffic.
for you to reach office in just 25 minutes?
No traffic.
No traffic. The road is completely clean.
Maybe he traveled with the car.
So now you are able to explain the reason for the variation. Now the variation you are seeing in your data is now called special cause. And the special cause is no traffic on the road. Because you started early morning, 6 o'clock, road is completely free. All of you, do you understand the difference between common cause and special cause? Common cause means you cannot explain. Special cause means you can explain. If you can explain, you are assigning a reason. You are assigning a reason. So this is common cause, this is special cause. And now tell me, one day you reached office consuming 55 minutes. Now there is a deviation. Generally, your expectation is 40. But now there is an excess 15 minutes. Is it a common cause or special cause? Come on, I expect a response. Is it a common cause or a special cause?
I lost it. What is the question? Right? It is within 60 minutes or 50 minutes.
Generally, you reach office in 40 minutes. But one day, it took 55 minutes for you.
It's a common cause, I think. Like it's only 10 minutes variation, and also it's a 10%.
Okay, you mean to say 10% variation is okay for you. 10% of 40 is 4 minutes. But here there is a 15 minutes. You took extra 15 minutes because there was a rain on the way. There was a rain on the way. So you have to slow down. And since you are able to assign a reason, this is now called as special cause. Another day, I think the question is now to Prabhakar. Prabhakar, now you took 1 hour 40 minutes to reach the office. Do you still consider this as common cause or special cause?
Special cause.
Because Prabhakar has met his girlfriend on the way. So Prabhakar has decided to spend 1 hour in a coffee shop. Am I correct, Prabhakar? Just joking.
Okay.
All right. So if you are able to assign a reason, it is called a special cause. If you are not able to assign a reason like the first case, it is common cause. All of you understand the difference? Common cause variation, this is special cause, this is special cause, and this is something very special for our Prabhakar. Yeah.
You will turn into wicked.
Just this. Yeah. So there are two types of variation. A process that is operating with only common cause is said to be under statistical control. Common cause is otherwise known as chance cause, also known as normal cause, also known as random cause. All are same, the jargons, right? Whether you call it common cause, you call it chance cause, you call it random cause, or you call it normal cause, or you call it unassignable cause, all of them are same. But a process that is operating in the presence of assignable costs is said to be an out of control process. Right? The assignable costs are also known as non-random, non-normal, right? Kind of thing. So now the process is called out of control. In an out of control process, points will easily appear outside control limit. In a statistical control process, points will always appear inside control limit. So this is called stability. If the process is statistically in control, the process, is considered to have stability. Stability means you are able to get all the points inside the control limit. If there is stability, improvement is possible. If there is stability, improvement is possible. Improvement means improving the capability. Whether the process has got the required stability or not, control chart will answer. Control chart will tell your process is ready for improvement if there is only common cause. If there is also assignable cause, your process is not ready for the next level of performance, right? So there are two things we are looking at process. One is stability of the process. Another one is capability of the process. Stability is there or not? Control chart can answer this. Once stability is ensured, capability can be measured. You can measure the capability using sigma level, using CPCPK, using DPMO, using yield or any metric. You can measure the capability. And if the capability is not healthier, you will think of improving the capability, which is called process improvement. All of you, do you understand the difference between process control and process improvement? Please confirm. All of you, do you understand the difference between process control and process improvement?
Yes. Yes,
So
sir.
all of you follow our guidelines of attending the training program. Process is under control. If all of you score very well in the exam, process is capable. For capability, stability is important. If all of you follow our guidelines, then only we can do much more for all of you. Isn't it? Same way. If your process is stable, you can improve its capability. If the process is not stable, you cannot improve the capability. So improve the capability means, statistically, there are two meanings. One is you will try to bring the control limit towards the center. Another one is you will move the center line towards the targeted value. Let us understand this by looking at a control chart. Yeah, see here. This is the process. When I move the control limit towards the center, I push this down, I push this up. This is called process improvement. This is called process improvement. When the control limits are pushed inwards, your process has become much more stable. Your products comes with high quality. This is called best in class products. Yeah. So I think I would like to take a pause here about the control chart, and then we'll continue from here. Once again in the control phase. So Ravi has come, so he is going to take us through the analyze phase. Ravi, I think Ravi will not mind just 2 more minutes, just couple of minutes, because I'll just show them how to plot a control chart, but the explanation will follow later. And see, I have a lot of data here, column number 1. This data is talking about diameter of a product. Length of a product. And every single time when the sample is taken, the company has the habit of taking 5 samples. This is called a subgroup, and the subgroup size is 5. And the data is length. Length is a continuous data. Ravi could have taught you. Now for continuous data, for a subgroup size of less than 8, we must go for a control chart. Control chart called control chart for subgroup. Again, X bar R chart. When to go for X bar R chart? Data type is continuous. Subgroup size is less than 8. stat, control chart, variable chart for subgroup, X bar R chart. And now all the data are in one column. Yes, we have everything in column number 1. So select that option, click here. Now Minitab is asking, where is that column? Indicate the column number 1. What is the subgroup size? I said 5. And now control chart option. I wanted to check whether my process is under control or not. Right now, only one thing I know about control chart. If a point goes beyond control limit, the process is out of control. If the process is inside control limit, the process is under control. The rest of the condition will talk to you in the control phase. Now the condition is added. Only first condition I have added. I have not ticked the remaining condition. Please here, I don't want to apply the other conditions. Other conditions require deeper understanding of the process. I don't want to consider other conditions. Give OK. Once again, give OK. Now the control chart is developed. Now the control chart is plotted. We have two charts. One is range chart, which you are seeing here at the bottom. The other one is X bar chart, which you are seeing here in this place. The range chart ensure the variation within every subgroup is under control. The X bar chart ensure the variation between the subgroup is under control. So what is this within variation or within subgroup variation? What is this between subgroup variation? We'll continue the discussion slightly at a later stage. So I stop here, and so that we can proceed with the agenda. So I just stop here. Also stop the recording.